Hello and welcome to this recording on IPv6 tunneling and the Sophos XG firewall. So this is a continuation of the series that I started last week. And last week we discussed the 6RD tunneling mechanism, um, which is the 6 rapid deployment tunneling mechanism, and we explained what that is, and also we demonstrated how to configure that on the Sophos XG firewall. In this particular recording, I'll be focusing on the 6in4 tunneling mechanism. So it's one of the oldest tunneling mechanisms. It's been largely replaced. Maybe that's not too accurate, but for the most part, it's been taken over by the newer 6 to 4 tunneling mechanisms and 6RD that we talked about last week. But still, it's still something that's still in use. There's still many device manufacturers like Sophos XG Firewall that have it implemented on their devices. Even Cisco have it implemented on their devices. So it's still something that's worth learning about, worth knowing. It's something that can contribute to our knowledge and understanding of operating IPv6 and IPv4 world. So just some basics regarding this. So last week, when we first started this, talked about the fact that the creators of IPv6 and also the different groups that are in charge of maintaining different standards and specifications for our common public internet, one of the realizations that they had was that for this to be adopted, there has to be some sort of compatibility between what we have now, which is IPv4, and what we're looking to move to, which is IPv6. In other words, you have all these huge ISPs, all these different service providers that have invested millions of dollars and pounds into their infrastructure, which is largely based around IPv4, right? So they've invested this large amount of money. We can't just come and say, yeah, we've got this new shiny protocol that we are looking to replace everything. So all the investment that you've made so far, now you have to replace them all. So that's not going to happen overnight. Um, it's a different question also. Will we eventually get rid of IPv4 completely? That's a question that we'll have to wait and see. But that's like the kind of mindset to approach this with. So what they decided was that there has to be some ways to maintain compatibility between IPv6 and IPv4, so that while we're moving towards IPv6, full IPv6 networks, at the same time, whatever we have is compatible with the current IPv4 networks. So we mentioned also last week that there are different mechanisms that makes this available or makes this possible actually. So we have the draw stack technologies, right? Draw stack technologies meaning being able to run IPv4 and IPv6 on the same device or on the same machine. So either it's your computer, your host, or network devices, or network security devices, that sort of stuff. So apart from dual stack, we also mentioned tunneling mechanisms, and there are different kind of tunnels that we mentioned last week. So for example, we have the 6in4, which is what we're talking about today. We have the 6 to 4. We have the 6RD, which is what we talked about last week. If you've not seen the video, I'll put the link in the description below so you can refer to that. We have the 6RD, we have Isotype, we have Tornado. So all these are different IPv6 tunneling mechanisms that are available. And one of the things that we have to realize is they serve different purposes. Um, some can serve the same purpose, but for the most part, they serve different purposes. Now, what do I mean by that? For example, we talked about 6RD last week. And one of the main things that we mentioned around 6RD is that this is geared more towards ISPs that are looking to provide their customers with IPv6 networks. So if you're an ISP, you're looking to start making this service available to your customers where they can have internal, full-blown internal IPv6 networks, while at the same time you're leveraging your existing IPv4 infrastructure to carry or tunnel through their packets out to the IPv6 internet or to some other IPv6 internal network on customer edge somewhere. That's get more towards ISPs. Now, what we're talking about today, 6in4, is a bit different. It's get more towards enterprises that are looking to connect two separate IPv6 networks. I've got a diagram that I'll be using for demo today. So let's go through that. So what we mean by that, we have an IPv6 network here. It's got this prefix of 2003 AABB 100 /64, and we have a separate IPv6 network here, 2003 AACC in this instance. This is AABB, this AACC 100 /64. So this is a separate IPv6 network. There's a separate IPv6 network. What we want to do though is have these two separate networks. We want to give them the ability to be able to communicate with each other, but what's the issue here? The issue is they have to go over the public internet, which is based on IPv4. So there's an IPv6 internet, but the internet that they're going through in this case is based on IPv4. So what we'll have to do is we'll have to get packets that come from this network here and comes to this firewall. So this firewall here, for example, will have to be a dual stack firewall, dual stack device. So have to be a dual stack device, and Sophos XG firewall supports this, which is really good. So comes in here, and then there has to be a way of encapsulating. So here we just put encapsulator of encapsulating the IPv6 packet here, encapsulating it within an IPv4 packet, sending it over to the other side, and then this other side will de-encapsulate it, or is it the encapsulator, and remove the IPv4 headers and then pass it on to this network here. Now, one of the things to mention with regards to all these different tunneling protocols, 6in4 that we're talking about today, is that the biggest disadvantage of 6in4 is that it is manual. So as we mentioned here, so 6in4 aka so 6in4 tunneling is also known as manual tunneling. It's also known as static tunneling. It's also known as protocol 41 tunnels. So that's the biggest advantage, is that it's manual. In other words, for every tunnel that you want to create going to any network, you have to manually specify where it's going to, and that's the biggest disadvantage. If you're trying to create connectivity between 100 or 1,000 IPv6 networks scattered around the world, then this can get really difficult to manage. It doesn't scale as well as some of the other different tunneling mechanisms like 6RD and 6to4, which we'll also be talking about. So just get ready. In this whole series, we've already covered 6RD. I'll be doing some more coverage of 6RD. Let's go a bit deeper in another video, and then I'll be covering 6to4, high setup, and Toledo. But this one, 6in4. Okay, so back to the network that we've got, and let's do the configuration on the Sophos XG firewall. It's a really simple configuration. Once we know exactly what we're doing, once we understand the concept, it's a really simple configuration. Before I actually do that, the other thing I wanted to show is I wanted to show this RFC that talks about 6in4 RFC. I'll put the description and the link below. So this is the latest RFC for that. And just point out some of the things that we've mentioned so far. So for example, we've mentioned around the concept of dual stack, which we talked about earlier. Dual relay, also known as dual stack, which is a technique for providing complete support for both internet protocols, IPv4 and IPv6. And then we've talked about different terminology in the previous recording around IPv6 only node, IP dual stack, IPv4 only node, all this different stuff. So it's a good RFC to go through. It's actually like one of the more simpler to understand RFCs. um, Encapsulation, which is the one that I talked about. So you can see here on our internal network, we've got this IPv6 packet. But what our device will do, what our Sophos XG firewall will do in this case is that it's going to encapsulate it with an IPv4 header. And then it's going to send it over the IPv4 network. And then when it gets to the destination will act as the role of the de-encapsulator, which we'll see down here, where the encapsulation happens. So when an IPv6, IPv4 host, which is a Sophos XG firewall in this case, receives the IPv4 datagram that is addressed to one of its own IP addresses or a joint multicast group address, the value of the protocol field is 41. That's another thing that we'll be pointing out. You see what this means when we're doing the demonstration. So because during the encapsulation phase, one of the things that it's going to do is that the IPv4 header, the protocol number will be 41. And the main reason, which is again one of the reasons why, if we go back to our whiteboard here, one of the aliases for 6in4 tunneling is protocol 41. So it adds into the protocol number field. And so the other hand can identify, okay, I'm receiving an IPv4 packet, but from this protocol number, I can assume that it's containing an IPv6 packet. In other words, this is an IPv6 packet encapsulated in with IPv4 header information. So then it takes away the IPv4 headers, does some checks. So for example, it verifies that the tunnel source address is correct. So once it can verify that the source address is correct, where it's coming from, in other words, you must have configured the source that it's coming from. You must have configured this source on this side. You must have configured this source on this side. So then when it checks that, oh, this is configured on my side, then it's going to go ahead and process it. So one of the things that I said is that if the source cannot be verified, the packet will be dropped and no ICMP message will be generated to say the reason why it's been dropped. So this is done by verifying that the source address is the IPv4 address of the encapsulator. Packet for which IPv4 source address does not match must be discarded and an ICMP message should not be generated. Okay, let's go through the configuration now. Let's bring up again my lab computer here. Show you what the configuration is so far. So I've got Windows 10 thresholds to one computer here, which is this one. And if I do an ipconfig, you can see that this has an IP address of 2003 AABB1001. And you can see the gateway is 2003 AABB1002. So back to a diagram, that is this guy here on this network. It has an IP of .1. The gateway, which is the interface, LAN interface of the UTM, has an IP address of 2 here. So, and you can see I'm connecting to the UTM, not the UTM, the XG firewall here on 2003 ABB 102. And it's the same for the other one. So for this other one, you can see that AACC in its own case, that's the difference, is that is AACC, that is ABB. Okay. So the very first thing I'll do to configure the tunnel is I'll go on this one. So again, just to show you, I can ping from this guy. I can ping myself, which is .1. I can ping my default gateway, which is .2. If I try to ping the other hand, the gateway of the other hand, which is AACC .2, no, not reachable. Has no idea what to do with it. Try to ping the host on the other hand, .1, no, not reachable. I have no idea what to do with it. So at the end of our demonstration, we should be able to ping the other end. So I'll go to system here. I'll go on the network. I'll go on the IP tunnel. Wow, these are hard. The IP tunnel. I'll call these IP 6in4, not 6 to 4. tunnel. And actually, to show you some of the things that are happening in the back end also. Let's increase this a bit. Let's make this clearer. Okay. There we go. We've got high net 6 address there for this spot. Okay. So, and then the other thing is we can check the existing route, which is let's make this larger so that it's more comprehensible for us. Here we go. That's better. So we can see it's just known about its own network and the port that that's located on. So what I'll do is I'm adding this tunnel type. I'll select 6in4. I'll leave the zone as a 1 zone. Local endpoint, what is that referring to? That is saying you're configuring this tunnel. Which IPv4 source address will it have? Where am I sending this out from? So this is where I configure that. So back to my diagram here, I'm going to be sending this out of the interface that's taking me out to the public internet. In this case, 192.168.10.2. So that's where I'm going out from, and I can verify that again from the command line here. So 192.168.10.2. So that's where I'm going. That's where I'm going to be going from, which is my local endpoint. But where am I going to? So this is where, again, remember that 6in4, that's the disadvantage, is that it's manual. I have to configure a remote endpoint for you to know where it's going to. So in this case, what I'm going to be saying is I want you to go to the other hand, which is this guy here. It's 192.168.20.2. It's the other hand. So that's what I'm going to be doing here. 192.168.20.2, which is the other hand. I'll just verify that quickly. So 192.168.20.2 is the other end. So let's go back. And then if I click on save, then it comes here and says IP tunnel, IP6in4 tunnel has been successfully created. Do you want to add route for remote network? In this case, yes. So what route do I want to add? So in this case, it's really simple. So I want to add a route. In other words, what it's asking me there is it's saying, okay, I know you're creating this tunnel between this interface here and this interface here, but I need you to tell me what networks are on the other hand. So that if I get a request from any host on my network here, saying I'm going to this other network, I know where to send it to. I know which interesting package to route over this tunnel. So that's what it's asking me to. So right here, it's not wise for me to go cancel here or just close this. That's not wise because now it just knows a tunnel exists. What packets do I send over this tunnel? It has no idea. So what I'm going to do is I'm going to say send anything going to this network, which is this network here. Send anything going to this network, send it over this tunnel. So I'm currently on this one, and I'll do the same from the other side too. So if I go back, just make sure, yep, got that enabled, and I'll just paste that here. So I'm saying anything, so I'm currently on AABB 102, saying anything going to AACC 100 network, prefix 64, send it through this tunnel. And if I save that, because actually, let's go back to the backend again. Let's see the routes that it's added so far. So you can see it's not really added anything so far, like anything really useful. So it's sending the link local, but nothing relating to the network that we're actually interested in. So that's what this one will allow us to do. So if I save there, and then that's done. So now if I go back and check the route on the back end again. Now I should be able to see AACC on my routing table. And where is it sending it to? It's sending it out of my tunnel over there. So that's good. So I'll just go over quickly and do the same on the other hand. So let's go over to this one and I'll do the same system network, and on the IP tunnel I'll add the IP tunnel again with the same name, IP6 in4 tunnel. So this cannot start with a number. 6in4, I'll leave the zone as 1. Again, in this case, local endpoint would be 192.168.20.2. Remote endpoint will be 192.168.10.2. So going back, 192.168.20.2, and remote endpoint is 192.168.10.2. So now creating this tunnel between these two IPv4 interfaces. I save it. Again, it's asking me, do you want to add any route for any remote networks? Yes, I want to, because there's a remote network here that this guy doesn't know about at the moment. So I'll add that to here. So for AABB in this case, it knows send it across this tunnel. So if I save that, and then that's done. Okay, so now you think, oh, all done, we have a tunnel already. Sophos XG Firewall knows the route to the network now. Everything should be all okay. But then we go over here and we try to ping the default gate or the gateway on the other hand. So I'm trying to ping this gateway from this guy here, and it's gonna fail. It's still gonna go, no, I can't go. Why? Why do we think that? One of the things that we can see is if we go back to GNS3 now. So I've got this. If I capture any traffic going out from here and bring that up in Wireshark, and let's see. So I'll install the update later. So let's see. So 45. Let's go back again. Let's just do a continuous ping. So I'm pinging the other hand AACC 101. But Wireshark, what is showing me? Nothing. Nothing is coming out. So I'm capturing anything going out through this interface here, and I'm not seeing this ping even going out of that interface. So the reason for that is, even though we've configured our tunnels, we have to set our security policies to allow that. So we're going to security policy under IPv6. We had a firewall rule. In this case, to make things simpler in a lab environment, I'll just call this IPv6 any to any. I'll disable that. I'll say zone. Again, I'll just say any to any. So in a production environment, you want to make this more secure. You don't want any to any. If you want to use NAT, which you can use, so you can select to use NAT here, and then I save that. So now I have the packet from this end going out. So what should happen now is that I should start seeing packet. But now I'm seeing request go out, but no replies. So on the other hand, I have to add a firewall rule also. So if I go back to this end and I go under security policy, IPv6, and just create a security policy to allow the packet also, IPv6 any to any. Let's add that also. Let's enable that. Let's leave NAT on and let's save that. And that's done. Now if we go back to our Win client, now here we go. Packet's been delivered successfully to the other hand. And if I try to ping this device now, so the ping that was successful was this gateway. If I try to ping this device, which is column 1, so if we go, oh, actually I'm pinging the other device, and I can ping his gateway for sure too. So I'm pinging 2003 AACC 100 column 2, and we can find out what the issue is there. But we know we can ping column 1, so that'll probably be another firewall. So if I go to the other hand, so this one, I can go on the system, on the administration, on the device access. So because I don't have ping 6 enabled here, that's why. So I can apply that. And if I go back again, I can ping the gateway, I can ping the device on the other hand. And also if I go to the other hand and I try to ping, so I'm on AACC now, if I try to ping AABB .1, yeah, that's successful. .2, I may need to add the firewall, sorry, the ping access again, which is under this one, under system, administration, device access, and had allow ping 6. So if I go back, I can ping that too now. And one of the things I want to show you is the Wireshark capture on the other hand. So let's stop all that. So one of the things that we see is that that's the packet going from and to. And so the reason why all these coming from to is because we're using NAT. If I stop using NAT, this will be coming from the device itself. So if I go to this guy here and I go modify my policy, my IPv6 policy, and I say, hey, I don't want to use NAT at all. I need to rewrite that. I do the same on the other hand, and I say there's no need to rewrite the source address. So the address that I'm seeing in my packet capture will change, and the address will be coming from. So because I've stopped capture, let's quit without saving. Let's start capture again, which is start Wireshark. Good, and then let's go back to this guy. Let's do a ping of the other hand. So they shouldn't be using any NAT anymore now. So if I go back here, I will just filter this by ICMP v6 and scroll all the way down, and I can see my ping request is coming from the device.1 itself, going to the device on the other hand. And if I do the same for the gateway, there's no need to NAT anything. So that will be from from column 1 to column 2, going to the other end. So one of the things I want to quickly just point out to you is you can see the packet, the IPv6 packet going out to the IPv6 destination. But one of the things is that you can see it's encapsulated in with IPv4 header. You can see the header length is 20 bytes, which means there's no other information apart from the header information. And you can see here is what we talked about. Protocol is IPv6 41. So that's really important because again, back to the RFC that we talked about. So when an IPv4 host or router receives an IPv4 diagram that is addressed to one of its own IPv4 addresses or a joint multicast group address, the value of the protocol and the value of the protocol field is 41. The packet is potentially a tunnel packet and needs to be verified to belong to one of the configured tunnel interfaces. So one of the first things it checks is if the protocol field number is 41, then it knows, okay, this is a potential tunneled packet. So this contains IPv6 packet that's just encapsulated with IPv4 header. And that's the protocol number there, 41 there, and then you can see the header is just 20 bytes. And again, if you go through the RFC here, 20 bytes, you can see the information that it's doing in the encapsulation is just adding 20 bytes extra as an IPv4 header to it. So I hope that's been very useful for you in knowing how to set this up on your Sophos XG firewall. And then I'll be doing another recording shortly on the 6 to 4 tunneling mechanism. Then I'll do iSetup, I'll do Tornado, maybe not on the XG firewall. I'll do iSetup and Tornado at some point, and also I'll come back to 6RD to give much more information. So I hope this has been very helpful and useful for you, and I'll see you in my next recording. Bye.